Hello everyone, Professor Dustin here. In this video I'm going to discuss modeling interactions as forces. So in the first part of this class we have modeled the interactions between objects as a transfer of momentum and a transfer of energy. That was very convenient when we knew that the energy of a system or the momentum of a system would not change, because then we could say, okay, initially we have this amount of energy and momentum, finally we have this amount of energy and momentum. What happened in between, as long as nothing leaves the system, we can keep track of how much energy and momentum there was, and we can solve problems that way. Forces gives you a little bit more of an intuitive way to think about how objects interact, because they interact because there is a force in between them. We don't really talk about why there is this force or the source of this force, just that there is a force which either pushes or pulls these objects either towards each other or away from each other, and that allows us to model the motion of the system. They're a little bit more convenient because, unlike the conservation of momentum and energy, we really think about that as one state, an initial state, and a final state, and really nothing in between. Forces really allow us to think about what happens to a system at every point in between the initial and the final state, can find the motion between the initial and the final state, and we can learn different things about systems. Traditionally, Newton and his contemporaries were the first people to come up with forces. That's how physics was presented in the initial 17th century. But now we actually think more about the conservation of energy and momentum sort of approach when we do modern physics, because it allows us deeper insights into why things in the universe move the way they do. But forces is still a very nice intuitive way of understanding these things. So that's basically why we want to use forces as interactions. They're more intuitive, and it also usually gives you a better idea of what's happening during the entire time period the system is evolving. So now I just need to introduce sort of the basic kinds of forces we have, which fall into two essential classifications. So these two basic classifications are contact forces and long-range forces. Some examples of contact forces include the normal force, the frictional force, and any sort of generic push-pull force. So if I push on a wall, that wall pushes back on me. That is a contact force because I'm making contact with the wall. Long-range forces include both the gravitational force and the electromagnetic force. If you are interested in sort of science as a whole, there are four fundamental forces: the gravitational force, the electromagnetic force, the weak force, and the strong force are also long-range forces. But in this class, we will really only be focused on the gravitational force. Physics 2, you'll talk about the electromagnetic force, and most of our time will be spent on contact forces. So just a note, these two classifications are very convenient, but when I say long-range forces, I don't mean really forces that require you to be over an extremely long distance. Long-range forces are just forces which are not contact forces, that objects do not have to be touching in order to be exerting a force on each other. That's a long-range force. In addition, all those contact forces are effective forces. The only reason we have a normal force is because of the electromagnetic force. The only reason we have a frictional force is because of the electromagnetic force. These are the forces that happen in between molecules that create the normal force, the friction force, the pushing force. So these are all the fundamental forces of the universe. But mostly we will be studying these forces in our everyday classes. Okay, great. So this has been an introduction to forces as interactions, and I've also given some examples of forces. Thank you for watching, and I will see you in class.